A balloon of volume 2000 meter cube is filled with hydrogen gas of density 0.09. So the volume of balloon so we have volume of balloon 2000 cubic meter and of dense is filled with hydrogen of density. So density of hydrogen 0.09 kilogram per cubic meter. If the balloon, the mass of the fabric is 100, so mass of balloon fabric (100 kilogram), and that of the pilot, the hot air balloon is piloted, so the mass of pilot is 75 kilogram. What will be the greatest mass of equipment that can be carried when operating in air of density 1.25 kilogram per cubic meter? So density of air 1.25 kilogram per cubic meter. Then how will this figure change if helium, which has twice the density of hydrogen, under the same condition, were to be used? Okay, so we are looking for the maximum equipment that can be carried, the greatest mass of equipment, or the maximum equipment that can be carried. That's what we are looking for. Maximum or greatest equipment to be carried. Okay. Now, in fact, we all know that the hot air balloon operates under the principle of flotation. What is the principle of flotation? A floating body displaces its own weight of fluid on which it floats. Or for a body to float, we all know two things: its weight of everything within the balloon. Okay, and what can be within the balloon? We can weight of balloon can actually be weight of the balloon fabric, WB, weight of hydrogen, WH, weight of the pilot, WP, plus the weight of the equipment. All this must be equal to the upthrust, or the weight of air displaced must be equal to weight of air displaced. We can also express this as mass of balloon, everything, mass of entire balloon, also equal to mass of air displaced. Now, to determine mass of the entire balloon, we need to have the mass of the balloon fabric itself, which was given as 100 plus mass of the pilot, which was given as 75, plus mass of hydrogen. Mass of hydrogen wasn't given directly, but we're given the density, and we know mass to be equal to density times volume. So with the given information, we can find the mass of hydrogen. M of hydrogen will be equal to density of hydrogen, which is 0.09 times the volume of hydrogen. The volume of hydrogen wasn't given directly, but we all know that gases take the volume of their container. So if hydrogen is within a container whose volume is 2,000 meter cube, then the volume of the hydrogen gas would be the same as the volume of its container. So 2,000. Therefore, we have 9/100, which is actually 0.091212. So we have 18 kilograms as a mass of hydrogen gas within. So plus 180. Now the mass of the equipment, we don't know. M of equipment, we don't know. But one thing that we know is that the mass of the entire balloon must be equal to the mass of the air displaced. So let's calculate mass of air displaced. Mass of air displaced is also equal to density of air, which is 1.25 times the volume of air displaced. Volume of air displaced, okay, would also be equal to the volume of the balloon, because when an object is submerged fully in fluid, okay, the volume of fluid displaced is always equal to the volume of the object. Okay, so if the balloon has a volume of 2,000 cubic meter, then volume of air displaced would also be 2,000. Therefore, what is 1.25 times 2,000? 1.25 times 2,000.
2,500.
So 2,500 kilograms. So we apply the principle of flotation, which is mass of the entire balloon must be equal to the mass of air displaced. So 100 plus 75 plus 180 plus mass of equipment must be equal to 2,500. We sum all this up. Sum them up for me. So 280 plus 75. 280 plus 75. This is
354.
Okay, so 355 plus mass of equipment. This is equal to 2,500. Then you make mass of equipment the subject, which is 2,500 minus 355. What will be the result?
2,145.
Okay, so 2,145 kilograms. This will be the maximum load that can be carried. or the greatest equipment that can be carried. Meaning that this mass plus the mass of the balloon plus the mass of the hydrogen and then the pilot must be equal to the upthrust. If you go beyond this, the balloon cannot float. If this is greater than the upthrust, the balloon cannot even go up to float in air. So this becomes the maximum or the greatest load that can be carried. Please, any question? So it's just, please, Caleb, mute yourself, okay? Or mute whenever you want to talk.
Yes.
Okay. So this is it. It isn't any difficult concept. You just need to apply the principle of flotation. Then the next question is that if the hydrogen gas is changed to helium, which is 2 times heavier than the density of hydrogen, what will happen? All that will happen is that this time we are told the hydrogen has density, which is 2 times the helium. The density of the helium is twice the density of hydrogen. So if the density of it is twice the density of this, then the only difference is that the mass of the hydrogen or of the helium will be twice the mass of hydrogen. Okay, so the only difference will be this, because density of the new gas is now twice the density of the old gas of hydrogen. So if the density of hydrogen is 0. This, then this will be 0.18 kilogram. Therefore, the mass is also expected to be twice. So mass of helium will be equal to the density times volume. This is the new density, 0.18 times the volume 2000. Okay, so it means that the new mass of the hydrogen will be twice the mass of this. So the only difference here is that this will not be 180. This time this will be 360. Mass of helium would increase to 360. Thereby, the maximum load would must reduce because the new air has a density or mass greater twice as this. So 100 plus 75 plus 360 plus the maximum load or maximum mass must be equal to 2,500. Okay, so it simply means that this will reduce by another 180. Okay, the maximum load that can be carried will be reduced by another 180. And we'll have 19,965 kilograms. That will be the maximum load to be carried. As simple as that. Please, any question? Any question? If you use weights, weight of entire balloon is equal to weight of air displaced, the only difference is that this will be times 10. So you need to divide through by 10 to get the weight, the mass. That's all. Is it understood? Are those of you who are not so clear?
Please.
All right.
Yes.
Then let's continue. I'll send you more questions on even this one and hydrometer, so that you test whatever you learned or we studied on the hydrometer as well. Okay, so in our last meeting, we were on moment. The moment of a force, which is the turning effect of a force. The turning effect produced by a force. And how do we determine moment or calculate moment? Moment is determined by the product of the force and the perpendicular distance. So it is this the reason for which moment is a vector quantity has to do with this perpendicular distance, meaning the distance has a direction. Force times perpendicular distance. Okay, let me clear this part of the board so that I can have everything there. So force times perpendicular distance. Moment is a vector quantity, meaning it has magnitude and direction. The direction of moment is taken from this, meaning that this distance isn't just any distance, but it is a distance with a particular direction. What is that particular direction? Its direction is that it must be perpendicular. It must have a certain direction to the force. Okay, so it is because of this aspect or part, and then the force is also a vector quantity. The reason for which moment is a vector quantity, not scalar. All right. So that's how to determine. Now, last time we saw that whenever you are given a force applied around a pivot or point of axis. Example, we have the pivot O, and then a force acts in this direction. Meanwhile, the angle to the force from the distance is theta. The distance from the pivot to where the force acts, we are saying is x. We realize that to determine the turning effect produced, you must resolve this force to get a component of it which is perpendicular to the distance x before you can calculate for the turning effect. So we resolved and then got this component. We realize that this component of this force, which is also the same as this component, will be F sine theta. Therefore, the turning effect or moment of this force can be equal to the product of the force, which is F sine theta, by the distance, which is x. Therefore, Fx sine theta. So when a force acts at an angle theta to the distance, this is how to determine. We can also be given a situation where the force, the distance can be act at an angle. Example, this is the distance d. This is the pivot or the axis of rotation. The length of this is equal to, this is d. And then there's a force acting in this manner at an angle theta. Okay, so this time what we do is that we can resolve to get a component of this which is perpendicular, a component of the distance which is perpendicular to the force F. So when we resolve this, we have this angle. If this is theta, this will be 90 minus theta. And so using sine of 90 minus theta, using 90 minus theta, which is this angle, we can find the moment. Of course, this component here, using this side, would be F, using this angle, would be F cos 90 minus theta when we use this angle. Don't forget, if we use theta, it will be this side, and it will be the same as F sine theta. Of course, sine theta is equal to cos 90 minus theta. And so the turning effect F, or the moment, can be the force times perpendicular distance, which is, oh, this side will not be F, it will be D, which will be either D sine theta, okay, or D sine theta times the force. Therefore, moment is equal to FD sine theta. So all that I'm saying is that you can either resolve the force or the distance to get a component which will be perpendicular to calculate the moment or the turning effect. Please, is that understood?
Yes, sir.
All right, let's quickly look at a couple system. Then we look at laws of moment. Then go to applications. A couple system, couple. Please mute yourself. I'm hearing Mintiaka. Adesu yebetua. Couple. You see, in our everyday expressions, we make use of the word couple. Couple. What do we mean by the word couple? Not directly related to physics here, but in everyday usage of the word couple. What do we mean by it? What do we mean by the word couple? Yes?
Two.
Two. So two what? Two what? We can directly say two, but couple. What do we mean? Oh, they are couples. They couple each other. What do we mean by a couple? Oh,
Two things of the same sort considered together.
okay, more views. More views. Another, okay, last view. Couple. A guy should express his view as well. Jojo. Caleb, you are here. Cadmiel, you are here. Kweku, Calvin, couple. Tell me what you also think. Oh, all right. So we'll take our sister's view that when we talk about couple or couples, we are referring to two people, okay, man and a woman that are into a certain relationship, okay. So in physics, we also have something like that, a couple system. What is a couple system in physics? When two forces of similar behavior, what do they have in common? They have the same magnitude. Okay, they have the same magnitude, but they act at different lines of action, or they act at different points. We in physics, we have acting at a common point or along the same line, but different points. If we talk about acting at the same point, Newton's third law of motion says that action and reactional forces are equal but opposites. So action and reactional force act at a common point, and this is the common point. So the same point. Okay, but if we talk about the two forces acting at a common line, but at different points, this is the common line. One may act here, another may act at the other end of the line. So here they are acting at a common line. This is the common line. But at different points. When you have two forces such that their magnitude the same, but they act at different points on a common line, it creates a couple system. It creates a couple system. So a couple system in physics is created when two forces of equal magnitude, so that are equal in magnitude, opposite in direction, and parallel. Not, you see, here you have to talk about the common acting on a common line, but at different points. So equal forces, okay, of the same magnitude, but act in opposite directions along a common, okay, a common line, create a couple system. An application of such couple systems in physics is, you see, whenever you are steering a wheel, driving, you hold the ends of the steering wheel. You apply a force up, down. So if you please, Alfred, mute yourself. Alfred, mute yourself. Okay, so you hold the steer at ends, okay, and then try to balance the wheel by occasionally turning it. So holding both ends create a couple system. Another application of couple system is riding a bicycle. Whenever you are, okay, put your leg on the pedal and then it's pedaling, you create a couple system. You exert equal forces in your leg, okay, in the leg, and they all act at a common point. Okay, so during steering a wheel, riding a bicycle, we see a couple system. And then if you've been observant, concrete mixer, whenever they are controlling a concrete mixer, okay, they steer, or the steering the concrete mixture also create a couple system. Can you share with me any experience or observations of couple system in use? Apart from these ones mentioned, can you identify any other couple system being in use? Yes. Can any one of you share a couple system? Yes. In opening the lock of the door using the key, whenever you are opening your door, you also see a couple system being in place here. Any more observations? Okay, I've given you more than 3. So look around. And then opening the tap of a standpipe, closing and opening the tap. We also see the couple system, okay, in use. All right, I've given you more than 4. So look around. So that is gears and transmission. It may be correct, but you must be familiar with it. We can have a lot of them, but some of them you may not be familiar with. That is why I am looking at those ones you can easily relate. Okay, opening and closing the tap. Okay, then what about screwing? Steering a car. Yes, I've talked about it. Then screwing a nut. All right. There may be a lot of applications. So this is what we mean by a couple system in. Oh, okay. I get you. This is what we mean by a couple system in physics. Now let's look at the turning effect. Rolling a boat, then it should be controlled by 2 people. Okay, because you can't roll the boat. Okay, one person cannot roll the boat at the same time. Closing a bottle top. Yes, it's similar to opening the key. All right, so that's it. Let's look at how to the turning effect. The turning effect of a couple system. A couple system is termed as the torque. TORQUE. So the torque in our situation, in our Ghana situation, is said to be the turning effect of a couple system. In the outside books, they use the torque to describe the turning effect of a force. Okay, but we mostly use the turning effect, okay, of a couple to be the torque. So we say that the turning effect of a couple system is known as the torque. How do we calculate or determine the turning effect produced by a torque? So if this is a common line, force F1, force F2. The distance, the perpendicular distance between them. Yes, each of the force must be perpendicular to this distance D. Then we can say that the turning effect produced, which is the torque, can be calculated by, you see, the two forces have the same magnitude. F1 is equal to magnitude of F2. So the turning effect produced is equal to one of the forces. We can even say that then they are all equal to F because their values, okay, are the same. So F times the perpendicular distance between the forces, D, gives us the torque. So if we have a situation like this, then the turning effect, which is the torque, can be calculated by the product of one of the forces, F1 or F, times the perpendicular distance between them. Sometimes there is an axis around which rotation takes place. So there's a pivot here. In the case of the steering wheel, the steer, you see, the steer is pivoted around, okay, or the turning effect occurs around something. There is a piston or a metal connection between the steer and then the wheel. And that is the axis of rotation. We take that to be the pivot. And the pivot around which turning effect takes place divide this perpendicular distance into two equal parts. So if the whole length is L or D, then the perpendicular distance between the pivot and this force would be D over 2. We'll have the same thing also here at the other end. This is also D over 2. So the turning effect in this case, if there is a pivot, can be calculated as the product of the force F times the perpendicular distance from the pivot to where any of the forces act, D over 2. So this is when there is a pivot, when the rotation or the torque occurs around a pivot. And this is when there is no pivot, but we are just looking at the perpendicular distance between them, the forces. So class, this is how to calculate the turning effect of a coupled system, which we are referring to as the torque. This torque thing isn't different from moment. That is why I said in foreign books, they use torque and moment as the same terms. Please, any question? Any question? If no question, then let's move on to the laws or principles of movement. Laws or principles of movement. Please, if you've read something on principles of movement, you can share with the house before we all look at it. What are the principles of movement? If you have the idea, share it with us. Okay, so principles of movement. Principles of movement. There are two key principles of movement. Okay. And This principles of moment works on equilibrium state of bodies or masses around acting at the same time around a bar. What do we mean? Look at the seesaw. This bar kind of seesaw where one end of it or the mid part is pivoted. Then we have an object here and then another object at the other end. Now, when this one object is greater than the other, there will be turning effects around the pivots. M1, M2. So if M1 is greater than M2 and their distances around the pivots are the same, X, this is Y. If X is equal to Y and M1 is greater than M2, there will certainly be turning effects. Why? It is because when we determine the turning effects by M1, we are saying that the turning effect, which is the moment, is the product of the force M1 times the perpendicular distance X. So the turning effect produced by mass 1 is this. Turning effect produced by mass 2, moment 2, is also M2 by the perpendicular distance Y. You see, X and Y are the same, but the masses are different. M1 is greater than M2, meaning that the moment produced by this will be greater than the moment produced by the second mass M2, because the difference here has to do with the masses. Don't forget, moment is equal to force times perpendicular distance. It means moment is directly proportional to the force. When force increases, moment will also increase. Moment is also directly proportional to the perpendicular distance. When perpendicular distance increases, moment also increases. But here is the case, X is equal to Y. So the perpendicular distance are the same. Meanwhile, it is the masses that are different. And so the larger one will be greater than the smaller one. Please, are you with me? Class, are you okay?
Yes, sir.
So
Yes,
if we have this situation, we'll certainly have turning effect. This one, M1, okay, pushing or tilting M2 up. So we wouldn't have a balance. We'll have this situation where M1 will be here and then M2 will be up here. The next turning effect will be in the direction of the bigger mass M1. So this will tilt M2 because the turning effect produced by this is greater than this. When we talk about principles of moment, we are looking at conditions that must prevail for equilibrium, equal turning effects. Okay. So the first principle of moment is that to obtain balance, where we have the level of the bar being the same, to obtain balance or to obtain balanced or equilibrium state, balance or equilibrium states. One, the sum of upward forces must be equal to the sum of downward forces. This is one way we can obtain an equilibrium state. Sum of upward forces must be equal to the sum of downward forces. Meaning that if this is a bar, uniform bar, pivoted here, if I have a number of forces acting, this is acting downward, F1. I have F2. Then, for balance or equilibrium state to occur, then this pivot must supply an upward force which will balance this, else the bar would even break. So for balance, the force produced by the pivot, which we will call as the reactional force. By the pivot must balance the total downward forces. So for equilibrium state or for equilibrium, the sum of downward forces F1 plus F2 must be equal to the reactional force R. So this is, for this particular illustration, this is one way we can obtain a balance. Or, assuming we have other forces acting upward, F1, F2, F3, then F4. Also here, then we can say that, okay, then sum of downward forces, F1 plus F2 must be equal to sum of upward forces, F3 plus F4 plus the reactional force for equilibrium to occur. Okay, so this is the first principle of moment, that to obtain balanced state or equilibrium state, one, the sum of upward forces must be equal to the sum of downward forces. And this is the principle that is used in building bridges and flyovers. You see, for bridges and flyovers, all manner of weight or load would move on the bridge or the flyover. So it must be calculated or estimated so that no matter the load that lies on the bridge, okay, their total weights or masses must balance the support given to the bridge. So when you are building bridges or even in structure buildings, and you don't support it with pillars, the pillars provides the reversal force. The weight due to gravity would act downwards. Okay. But the pillars under the bridge, the pillars under the story building will provide the reaction, the upward force. So if you don't choose the materials in such a way that it would always provide a force, which an upward force, which will be greater or equal to all the downward forces, the bridge will collapse. There wouldn't be equilibrium state. It would move in a downward direction. The moment the net force acting down is greater than the upward forces, there will be movement. You wouldn't have equilibrium state and it will collapse. So this principle is also factored in the building of bridges and even story buildings. Mamiya.
Yes, I'm not really understanding the reaction force.
You see, the reaction force is such that, Mamiya, if you are assuming this is a story building, what we have here is a story building. These are the pillars which support the building. There's the ground. We don't expect a vertical motion. So no matter the number of people that goes into the building, this is Mamiya. This is Mamiya's sister, Mamiya's brother. No matter the load, okay, each of you is exerting a weight, some force due to gravity, depending on your body mass. Mamiya is slim, so small weight. Mamiya's sister is fat, larger weight. Your visitors, and okay, so you are exerting various forces on this. In building, these pillars must be able to support the number of occupants within the room. The pillars provide the upward forces, which we are calling as the reactional force. Mami, are you there?
Yes, please.
So the pillars provide the reactional forces to balance the numerous people or load acting on the building. So for equilibrium, we don't want a vertical movement, whether the people are moving. Of course, the pillars cannot, the force produced by the pillars cannot move up due to gravity. But if we have a situation where the total weight of people on the story building is greater than the reactional forces provided by the pillars, we wouldn't have a state of balance. There will be downward movement. And whenever downward movement comes in, we have the building collapsing. So for that stability or equilibrium state, the total downward forces must be equal to, at least, must be equal to the total upward forces, which are the reactional forces produced by the column. That's what I mean. So in building bridges, flyovers, we don't choose any material. You have to be careful. You have to that is why it is done by engineers, because they need to know the vehicles, the number of vehicles, the kind of vehicles that will be using the bridge. Else, if you choose any stupid material, it can one day collapse and then cause accidents. So engineers must check the number of vehicles and then the type of vehicles that use the road. Knowing this would inform the reinforcement to put in so that the bridge will not one day collapse. I mean, that is what I'm saying.
Yes,
You got
please,
it?
I understand.
Yes, so they don't just stand up one day, oh, we are going to build. They actually survey to find out all this information before they choose materials and all that. Else, accidents can really occur. So one key principle they apply in said construction is this one. The sum of upward or downward forces must be equal to the sum of downward force. Actually, it must be the sum of upward forces must be equal or greater. Must be equal. Sum of upward forces must be greater or equal to the sum of downward forces, and not the other way around. If you do it to be sum of downward forces must be greater than sum of upward, oh, accidents would occur. But what is the reactional forces must be equal or greater than the action or downward forces. Please, any question? Jojo, are you there? Caleb, are you there? Calvin, Safo. Okay. Then the second principle of moment says that the sum of clockwise moment, the sum of clockwise movements must be equal to the sum of anti-clockwise movements. That's the second principle of movement. For that balance or equilibrium state to be obtained, the sum of clockwise movements must be equal to the sum of anti-clockwise movements. Or this can also be rephrased in a different way, and that is the net torque in one direction must be equal to the net torque in the other direction. So either you state it as this one or this one. How do we illustrate this second principle? We have pivots or a rigid bar. Pivoted at some parts of the rigid bar. We have this force. We have this force. F1, F2. Let me introduce another force. F3. F1 is at a distance of X from the pivot. I have this force. Let me even use these two illustrations. Now, this force is acting downwards. It's similar to using this and then exerting a force in the direction of F2. If this is the pivot where my hand is, the position of my hand is the pivot. If I exert a force in the direction of F2, it will turn the bar in this direction. So you see, the bar turns in the clockwise direction. Let's look at F1. If my hand is a pivot and I want to exert a force in the direction of F1, it also turns the bar in that anti-clockwise direction. So you look at the forces here, which will give you clockwise and anti-clockwise movement. F2 turns in this direction. This is clockwise. F1 will turn in this direction. This is anti or counterclockwise. What will be the direction of F3? Class, what will be the direction of turning of F3? Ideas.
Please, I think it will be clockwise.
Why? Why do you think that will be clockwise?
Because it will be going up.
The unfortunate thing is that if a force acts at the pivot, it will not give you any turning effect. The reason is that the moment here, moment is equal to force times perpendicular distance. If we are to calculate, the force is F3, but there's the perpendicular distance from the pivot is 0. So if a force acts at the pivot, the turning effect produced is 0 because there is no perpendicular distance. Please, is that understood? Class, is it understood?
Yes, sir.
Yes, please.
Good. So this is clockwise, this is anti-clockwise. And the rule says that for balance or equilibrium state, the sum of clockwise movements must be equal to the sum of anti-clockwise movement. So assuming this distance is y, then clockwise movement is equal to F2 times x. Anti-clockwise movement is equal to F1 times the perpendicular distance y. And for equilibrium to occur, this must be equal to this. Then there wouldn't be any turning effect. The moment one is greater than the other, it will turn in the direction of the larger torque or moment. So for balance or for balance or equilibrium state to occur along the bar, sum of clockwise movements must be equal to the sum of anti-clockwise movement. These are the principles of movement. And it is these principles that will be used to calculate for problems. Please, any question before we illustrate solving a question? If you have any question, quickly ask before we apply whatever we've learned in solving a problem. Okay, so let's try solving a problem with Julian.
Sir, please, what's the unit calculating moment?
Oh, unit force times perpendicular distance. Force is in Newton, then distance is in meter. So Newton meter. That's the SI unit. All right.
Yes, sir.
This unit has not been honored to any scientist. So maybe Julian, if you work hard, we'll honor you with the unit. So that we'll not be mentioning Newton meter again by Julian. Okay, so a question. So find, let me change my marker. Find the sum of the moments about O. And there's a diagram. There's a pivot O, the point around which this turning takes place. We have forces 6 Newton. We have 5 Newton. Then we have 3 Newton. The perpendicular distance from the pivot O for this is 2 meters. Then for 5, this is 4.5. Then from here to here is 3. You have to find the sum of the moment about O, or the sum of the moment or the next torque or moment. So let's give it a try. From the pivot to this is 2 meters. Then from this force to this force, 4.5. Then from the 5 Newton force to the 3 Newton force, this is 3 meters. So find the net torque. So you have to determine the net torque or the net moment. Let me take attendance and then get back to it. So we are using about 6 minutes for this, please. Are we through? Hello, do we discuss it?
Yes,
Okay, so let's begin to look at it and then solve other questions as well. All right. So what did you get for net or sum of the moments? Let me pick the answers of some of you. Hey, what have you had as the sum of moments? Leonard, what is your answer? Eva, what is your answer? Della? I've mentioned 3 names. Della? Hey, The line is gone. Frida. Hey, they are all hiding. Wow. Kasha. Kasha.
Yes, sir.
Can you share whatever you had with us?
Sir, please, I'm doing my conclusion. I'm still on it.
Hey, okay. Time sake. So let's see. How do we determine the net stock or the sum of the moments? You look at the individual 73 sample. Okay, thank you. We'll look at it. You look at the individual forces and the turning effect it will give you. What turning effect will this give you? The 6 Newton. Will it be clockwise or anti-clockwise movement? Will this give us clockwise or anti-clockwise movement? The 6 Newton force.
Please,
Hey,
anti-clockwise.
Anti what? Clockwise.
Yes, please.
Mamiya is the only one contributing. Cadmiel, Leonard, Audrey, talk. Mamiya, why anti-clockwise? Tell me how you got it. How did you manage that the turning effect of this will be anti-clockwise?
Because if it is turning in that direction, it's not moving in a clockwise manner. It will be coming down.
Mamiya, look at my illustration. The rule is the bar. We have 6 Newton force, 5, and then 3 acting on it. Which direction is the 6 Newton force? Which direction is the force going?
It's going
It's downward.
Downward, meaning assuming the marker represents the force. If I push it to the direction of the 6 Newton, is it turning upward or downward? Is the bar turning upward or downward, Mamiya?
forward.
So which direction is this illustrating?
Clockwise.
Clockwise. So this will give us clockwise movement. The axis of rotation is actually around O. Let's look at the 5 Newton. The force is going upward. So if I'm to push the bar in the direction of the force, will it be clockwise or anti-clockwise? Mami?
It's clockwise. Anti-clockwise.
This is anti-clockwise. So the 5 Newton force would also give us anti or counterclockwise. So instead of the whole writing, let me use C for clockwise, A for anti-clockwise. What about the direction of the 3 Newton force? Will it be clockwise or anti-clockwise? Without illustrating. Oh, hurry up. Anti-clockwise. It will go up. The guys are quiet. Oh, Samuel. Just say whatever you think, and we learn from there. Go. So we have identified the direction of all the forces around the pivot or along the bar. Okay, so let's calculate sum of clockwise movement. For clockwise movement, we have only one, the 6 Newton. Okay, and moment force times the perpendicular distance from the pivot. So 6 times, what is the perpendicular distance of the force from the pivot? Yes. What's the perpendicular distance? Pardon?
2.
Please.
2. This is 2 meters. So the sum of clockwise moment is equal to 12 Newton meter. Let's come to the sum of anti-clockwise moment. We have 2 of them. 5 times. Okay, so what is the perpendicular distance from the pivot? The 5 Newton force. What is its perpendicular distance from the pivot?
4.5 meters.
Pardon?
4.5 meters. No, wait, 6.5.
It's 6.5. 4.5 is from the 6 Newton to the 5 Newton. So the perpendicular distance is from the pivot. So 2 plus 4.5. So 6.5. Plus the other anti-clockwise moment. 3 times. Yes, 3 times.
3. 9.5.
9.5. So what is 5 times 6.5 plus 3 times 9.5? This is 32.5 plus 28.
61.
61
Okay, 61 Newton.
meters.
So the net or the sum of the moment or the net moment is that, you see, we are saying that the principle must be that for equilibrium or for balance, summation clockwise moment must be equal to summation anti-clockwise moment. And look at them. This is greater than the clockwise moment. So the difference gives us the net moment. So net moment is equal to 61 minus 12 Newton. And what is 61 minus 12? What is 61 minus 12?
49.
So 49 Newton meter. So the net moment or torque is in the direction of the anti-clockwise movement. So it is just like tug of war. Okay, you pull and I also pull. Whosoever provides the larger force wins. Okay, so if I win, it means I will move all of you in my direction. So if it is seesaw, those anti-clockwise movements would turn the clockwise, those in exhibiting clockwise movement in their direction. So the anti-clockwise movement wins, or the next turning effect is in the direction of the anti-clockwise turning effect. This is what it means. Please understood?
Yes, sir.
So if you are given these situations to calculate the next moment, that is basically what it means. All right. I'm going to give you another one to try. This time I will not come in. You must do it yourself. You must really do it yourselves. Okay, so the forces acting, please, I'm reading the question, put it down. The forces acting on these rods are in equilibrium. The forces acting on these rods are in equilibrium. Find the value of the unknown forces or distance. So we have set of questions. So find the values of the unknown forces, and I'm going to give you two questions. Question one. There's a diagram. It is pivoted. We have two forces or masses here. 8 gram. You have another mass, 6 gram. Distance between here 30 centimeter. Distance between this 50. There is an unknown force here, P. Then we have this mass of 20 gram, which is unknown. The distance X is also not known. So find the unknown masses and the distance.
Mr. Edia, please, what is the value on the upward?
That is P. It's unknown. P is unknown. We have to find it, okay? Question 2. We have the bar. This is Y. This is 3 gram. Five gram. This is X. This is 1 meter. Another 1 meter and 2. So we are looking for the unknown variables in the question. Start work as usual. 6 minutes. Learning.
Sir, please, the figure on the left of the 6G, what's there?
That is 8 gram. What is this is 8 gram, okay. The reflection of light. Are you done? Hello. Okay. I'm sure you are done. Do we discuss it? Hello.
Yes, please.
So, question 1. What did you make for P? What did you make for P? The unknown force P. Yes. What did you make for P? Anybody? Oh, I don't like this, your silence. Let's share ideas. Getting it wrong is part of learning. Share your, whatever you've done, your work. What did you make for P? Hey, no one is talking. Okay, let me go ahead. Hi. If you don't stop doing that, if you don't stop keeping quiet over questions, I'll close class and then leave you. Let's share ideas. Whatever I always say, getting it wrong is part of learning. Oh, Mr. This is what I got. How did you get it? Then I'll let you know whether you are on the right path or you are wrong. But to ask and then everybody being quiet, isn't the best. So what have you been able to make for P? Okay. If you are not talking, then I think we have to close here because you are not even ready to share whatever. So this is where we draw the curtains on today's meeting. We'll meet again. Bye-bye. But that's not right. I'm asking you a question. Tell me what you've had and you are quiet. So what do you want me to do? You want me to be the sole contributor? Is that how we learn? Share with me what you have, and everybody is not talking. What do you want me to do? If you'll be ready to share whatever you have, fine. If you are not, I think the best way out is to end the lesson. So the choice is yours. Okay, bye-bye. We'll meet.